Welcome to the Water Environment Research Foundation's TERI tutorial. This segment of the tutorial will walk you through how to use the results and outputs from the tool to evaluate resource recovery to assess your plant's potential to recover nutrients. After you have finished entering all of your data, it is time to review and interpret the results. An overview of the performance of your system can be accessed by clicking on the Plant Mass Balance text at the top of the screen or by clicking the MB Schematic tab at the bottom of the screen. Both of these links will open your plant's mass balance schematic diagram based upon the data you have entered. The plant mass balance schematic diagram shows the distribution of total suspended solids, total nitrogen, and total phosphorus throughout the plant prior to nutrient recovery. Wherever you did not enter data, the mass balance box for that area will not contain any numbers. This information gives you an estimate of the amounts of nutrients that are available for recovery in the various streams through the plant. In this particular example, the numbers in the side stream box of the plant mass balance shows an estimate of the amount of phosphorus and nitrogen that are concentrated in the dewatering process side stream. This is used as a basis for the estimate of the amount of nutrient that can be recovered from this side stream and the estimated cost of the recovery system. Based on the data you have entered, the TERI will also calculate the expected performance and preliminary cost estimates for struvite recovery as compared to removing phosphorus with ferric chloride or alum addition. The performance and costs results table can be accessed by clicking on the Capital and O&M Estimate Results button at the top of the main navigation screen or by clicking on the Results Struve tab at the bottom. The comparison table highlights the major performance and cost differences between struvite recovery systems and chemical precipitation processes. You will notice that there are two different struvite crystallizer options included in this table. This is due to the fact that there are a variety of different processes on the market today that can be used to recover struvite. The costs for these technologies vary significantly. The struvite crystallizer high estimate and the struvite crystallizer low estimate are meant to represent the full range of costs for these systems. Please note that the upfront capital costs of these systems are estimated as well as the maintenance, labor, and parts costs. The BCE uses the business case model criteria that you entered previously to calculate scores for the baseline scenario to compare to the struvite recovery options and chemical precipitation options. Please note that the baseline scenario represents the condition where plant O&M staff take the necessary operational and/or maintenance steps to minimize the effects of nuisance struvite formation. The net present value is the present value of the revenues minus the present value of the costs for an alternative. TERI uses a 20-year time period for this evaluation. The contribution to total score table shows a breakdown of how each category of the business case model criteria that you entered affects the total score of each alternative. In this example, the struvite recovery from side stream flow low estimate scored the highest, indicating that this alternative meets the business case model criteria that you entered most effectively. The three remaining tutorials in this series walk through three case studies to show examples of how TERI is used for different types of facilities that have different types of input data available. It may be helpful to identify the case study that is most similar to your facility and to review the tutorial for that particular case study in greater detail.